So what we have here, guys, is the graph shows the depth of water of y centimeters at a point P during a 9-hour period. The time is given to you from hours from midnight to 9 o'clock. So when you start off here at midnight, and what you have is you're at. Can anybody in the class tell me how many blocks are there in between each one? There seems to be. So there's 4 blocks. So 4 blocks is worth 12. So if 4 blocks is worth 12, 1 block is worth 3. Now this one is 1 block short of 84, which means that it starts off at 81. Okay? So it goes, use the graph to find the estimate of the value of t when the depth of the water is a minimum. When is it a minimum, guys? About this one here. It's in between 6 and 7 o'clock. So we'll just count the blocks on the x-axis as well. How many blocks are there in between each one? Is it 5 or 6? 1, 2, 3, 4, 5. Does everybody agree that there's 5 blocks in between 1 and 2? Is it 5 or 6? 5. So, are you listening? 5 blocks equals 1 hour. So what's 1 hour divided by 12? Or 1 hour divided by 5? 12 minutes. Do you understand that? 12 minutes. So 1 block will be equal to 12 minutes. Okay. Need everybody paying attention, please. Okay. So the depth of water is a minimum. Okay. It's around 12 minutes underneath 7 o'clock. So what would you say? About 6:48 a.m. Is that right? When's the maximum? Maximum's up here. Let's go straight down. What do we get here? Just after 1 o'clock. 1 block after 1. 12. Okay. Some of you could probably might have wrote that in decimals, which is also okay. Like 1.2 or something like that. 12 a.m. When is the depth of the water increasing most drastically? When is the slope at its sharpest? I'd say almost at 9 o'clock, because see the way at 9 o'clock, see the way the tangent is like that? At 8 o'clock it'd be more like that. On this one up here it'd be more, which one's the steepest line I drew up? Which is the steepest black line I drew going upwards? Sorry? It is increasing from 8 to 9, but when is it increasing most rapidly? Do you remember what we said about the cubic functions? They come up, then they go down, and then at the end they really start going up very steeply. Okay, so what I'm saying there, guys, is I showed you 3 different slopes. Which slope is the steepest? If you were like climbing a hill, which one would you have the most trouble? The 9 o'clock one. Okay, so we're going to concentrate on the 9 o'clock one. Okay, write down the value of t. We'll say 9 o'clock. Everybody alright with that? Many people got them out, more or less, like just ever so slightly different answers maybe. Okay, now next part after that. The depth of the water can be modelled on the function t cubed minus 12t squared plus 24t plus k, where k is the time, or t is the time in hours after midnight. Write down the value of k. Remember what I said straight away is that what you can do is, see this up here. What value did I say that was again? 81. When t equals 0, the y value equals 81. Would everybody agree with that? Because that's 0, 81. So what you do here is this. Replace all the t's with zeros. So y equals something cubed minus 12 times something squared plus 24 times something plus k. The y value is 81. The t value is what, guys? 0. What's 0 cubed? 0. 12 times 0 squared? 12 times 0. 81 equals k. Therefore k equals 81. Anybody get k equals 81 last night? Is it 81 in the back or 80? What? Is it 80? Alright, it probably should be 81 though, because it is, unless I flip this out, it's exactly one block underneath it, and each block's worth 3, so I'd argue I'm more accurate this time around. Okay? Now, by using dy dt, find the rate of change of depth at 300 hours. What's the t value at 300 hours? 0, 300. What's the t value? It says t is the time in hours after midnight. So how many hours after midnight is 3 a.m. in the morning? So t equals 3. We know our function now is the depth function. This tells us how deep the water is with regards to the time. We know that it's now like this. Now, how do we find dy dt, Sam? And what happens when you differentiate? 3t squared, yeah? Minus 24t. Okay. And it says that we specifically have to do it when t is 3. So what would that mean next? What would it mean? Sub in 3 for t. And then what happened then? We'd put in 3 squared. Put in red. 3 squared minus 24 times 3 plus 24. What you get? Anybody? Sorry? Minus 21, is it? Minus 19, guys. Okay, so just use the calculator. Make sure you get the answer out without any mistakes. Alright, moving on to number 9. A car begins to slow down in order to stop at a traffic light at Q. The distance from P after t seconds is given by s equals 12t minus 3t squared, where s is the distance in meters. Find the speed of the car as it passes by P. Now let me explain what's going on. Your job is to travel from here, and your car is going to stop. Its speed or velocity is going to be what when it reaches the lights? 0. It's going to be stopped when it reaches the lights. Okay, that's the first thing we know. Second thing we know, we're trying to figure out is what does this equation actually mean? So what we're going to do is we're going to start the equation. We're going to put it into the calculator like I tend to do a good bit. So 12x minus 3 over 2 x squared. You look at this and you start at 0, and we don't really know how high to go up, do we? So you just take a relatively large number, like something like 20. Okay. Now what does it say t is measured in again? Seconds. So I'm taking 20 seconds in the future. It might not be enough. If it's not enough, I'll just put in a bigger number next time and spread out the gap. Okay. Now look what happens. What this means is that how far is the traffic light away again? Car begins to slow down, or so the distance of the car from P is this, where S is in meters. Okay, perfect, right? So what happens here, guys, is that you start off at P. After 1 second, you're 10 meters down the road. You're up here. After 2 seconds, you're 18 meters down the road. You're 22 meters. You're 24 meters. What's the furthest we got away from it? 24 meters. And then all of a sudden, we start going backwards. We come back where we came from. Do you understand that this function, this side here, gives you how far did you travel away from this point here? So what this happens in this question using this function is your car decelerates, it stops here, and then it goes backwards again. So we only need to worry about the first half of the equation, is what I'm trying to say. So if you assume that you're going to stop and you're not going backwards, this is what happens. After 1 second, you're 10.5 meters away. After 2 seconds, you're 18. After 3 seconds, you're 22.5 meters. At 4 seconds in, you're 24 meters away. After 4 seconds, you start to go backwards. So that means it doesn't matter for any value above 4. 4 is when you reach your maximum distance away. So after 4 seconds, guys, what we reckon is going to happen is that after 4 seconds, you're going to be 24 meters away, and your car is momentarily going to stop. Then it's going to start getting closer to where it started from. Let's see if the maths backs this up. If the first formula is the distance, what is the differentiated formula? Speed. Okay, everybody should know that by now. You differentiate, and what you get? 12 minus 2 multiplied by that is going to be 3t. Remember, we predicted 4 seconds. T equals 4, and it's 24 meters away. Let's see if this happens. What happens when you stop at the traffic lights? Your speed is equal to 0. Your speed equation, which is this, is going to equal 0. 12 minus 3t equals 0. Bring over to 3t. 12 equals 3t. What does t equal? 4. Now, the wording of the question is very important. Find the speed of the car as it passes P. Oh, sorry, I've actually gone to part 2. My fault, I went straight to part 2. Part 2 is find the time taken to stop. That's t equals 4. You then get your original equation and you replace t with what, guys? Sorry? You replace t with 4. And you replace t with 4. I've already had this worked out on the calculator here. When t gets replaced with 4, the answer is 24. So you're 24 meters away when you stop. Does that make sense? Now, I forgot to do part 1. The speed of the car as it passes P. When you pass P, what is the time? At the very beginning of the question, what's the time? 0. What's the speed equation? 12 minus 3t. So replace t with, anybody? 0. 12 minus 3 times 0? 12. 12 meters per second. Okay. Number 11. The volume of water feet in centimeters cubed that remains in a leaking tank after t seconds is given by this function. Mick, what type of function is this, do you think? What type of function do you think is question 11? The shape of it, what shape would you say it would be if you were to graph it? Nearly?
A U shape.
It's a U shape, okay? Reason why it's a U shape?
Because there's the squared in it.
Yeah, if the squared is positive, if a plus comes in front of the squared, it's U-shaped. If a minus comes in front of the squared, it's N-shaped. So it's U-shaped, okay? Now, we can have a quick look at what is actually going on here, okay? So what's actually going on here is you go to your table function, you enter in the formula, and you're actually going to see what's going on. So 300x plus 0.5x squared. I have no idea, once again, of the scale. So I'm just going to go 0 to 20 again and see what happens. Now, can anybody describe what is going on here? It starts off at 45,000, and what's happening every second? Sorry? It's getting smaller and smaller and smaller. Is there any point where we see it getting bigger? Not really. Keeps going down for the first 20 seconds, doesn't it? So what we're going to assume is that this graph, we want to find the first, we're going to need probably the first 50 seconds, okay? So what we'll do in a case like this, guys, is we'll go back, we'll do this. Now I'm purposely going to make a mistake on you right now, okay? Here's the mistake I'm going to make. I'm going to enter in 50 here, and it's going to be a step of 1. It's going to tell me insufficient memory. Do you know why? That is 50 different points. 0, 1, 2, 3, 4, 5, 6, 7, 8. Too many. So what we're going to do is we're going to go back again, and instead of going up in ones, we're going to go up in fives. So it'll tell me the volume every 5 seconds. Okay, so what happens here, guys, is look at this. After 5 seconds, it's at 43,512. After 10 seconds, it's at 42. After 15, it's still dropping. Now what happens after a certain point? It's still going down. It's going to just continue to go down for all 50 seconds. Is that okay? So what you're aware of is that for your first 50 seconds, you're going to get a drop. It's this side of the N-shaped curve. So your volume is dropping all the time. Sorry, in a U shape, there's a very poorly drawn U. Excuse me. I'll try it again. More drawn like that, okay? Something like that. Okay. There, that's better. Okay. So it's dropping all the time. Now, after how many seconds will the tank be empty? Now, that's a tough one, alright? We still haven't found it, have we? Let's try going up in tens, guys, okay? Let's, instead of going up in, sorry, I have to do this again. It was still full at 50. Would everybody agree with that? It was still full at 50. So why don't I take it like an end of 200? 200 seconds. Step at 10. Look what happens now. Are you looking? Let's keep going down. Past 50. 60, 70, 80, 90. We're nearly there now, aren't we? It's getting really, really small. It's above 200 seconds is when it turns to 0. So go once again. You haven't really done any maths yet. All you're doing is just using your calculator a good bit. And then we'll go up in tens again. Hopefully it has memory. No, it doesn't. Let's go again. 350. Sorry? It's empty at 300? Okay. Well, I still have to figure out that it's empty at 300. So I'm going to go up in the step of 20 this time. Okay. And look at this. Keep going down. You can see it's getting emptier and emptier and emptier, and then finally at 300, completely empty. That's just knowing how to use your calculator function. Nothing more, nothing less. Now, let me show you how you're going to do this. It's empty when your volume equals 0. 0 is equal to 45,000 minus 300t plus 0.5t squared. Now, have we ever done a quadratic equation that has a 0.5t squared in front of it? So we've never done a quadratic equation like this before. So what we're going to do is, instead, do you know the way we usually divide by 2? This time we're actually going to multiply by 2. And let me explain why. So 1t squared minus 600t plus 90,000. Now, have we ever done like anything this large before? No. So if you haven't done that, if you're worried you don't know how to reference number it, the minus b formula will always give you the answer. A is 1, B is minus 600, C is 90,000. Okay. Now we know that time has to be the positive answer, doesn't it? Time can't be negative, so we need a positive answer here. Okay. So what we're going to do is we're going to write down the minus b formula. Should all be familiar with it. And what we're going to do is we're going to plug in our numbers. Minus b being, anybody? 600. Plus or minus, minus 600 squared. Sorry guys, we're actually going to need a lot more space here for this one.
Why didn't you just differentiate 1 so that equals 0?
That's the maximum turning point. It's not guaranteed to be 0. But I'll try it that way afterwards, okay? It's okay. So guys, let me show you something else here. So, okay guys, minus 4 times 1 times 90,000. Is everybody happy with that? All over 2 times 1. Let the calculator do all the work for you, okay? We don't want the negative 1, we only want the positive 1 for the most part. But look, let's find out for sure. What we're going to do is going to write in the square roots. Do you see this part here? I'll colour in this. I'm only going to do this part first. And I do this part first. I'm going to get his root minus 600 squared minus 4 times 1 multiplied by 90,000. And what we get here is 0. It's worth nothing. Okay? So there's only one answer to this question. 600 divided by 2, which equals 300. Now, what Sam made a prediction was, Sam's prediction was this, that the answer is 300, we knew that already. Sam's prediction was that because it's based on a U-shaped function, the lowest volume has to be a minimum. You got that? has to be a minimum. Technically isn't true, but I think for this course it's a good gamble. Okay, so he gambled it on it being a minimum. What can you tell me about the slope of the minimum? The slope of the minimum has to be 0. So what you're going to do is you're going to differentiate once and put it equal to 0. So when we differentiate, what do we get? That's a V, isn't it? Capital V. Okay, differentiate once, Sean, what you get? 45,000 turns to? Minus 300t.
Minus 300.
Okay.
Plus 2 times 0.5.
2 times 0.5? 1t equals 0. Bring over to 300. T equals 300. It's a much quicker way, a lot more efficient. Last thing, guys, is this is most definitely on your course. Find the rate of change with the volume when it's at 50 seconds. The volume is always on its way down. Would everybody agree with that? If the volume is on its way down, it's a negative slope. The volume of the slope, what's the equation of the slope, lads? The equation of the slope is this here. What are we going to replace t with? 50. So it's going to be minus 300 plus 50 equals minus 250 centimeters per cubic meters per second. Finally, you're going to have a test on differentiation. You have all weekend, and you're going to have it on Monday.